Hello, welcome to online classes of YouTube session. Today we will discuss the formation of differential equation. So, how to form a differential equation from a given function, we will discuss about that. So, first the procedure, I will say the procedure, after that I will do examples. Okay, let's come. Okay, first procedure to form a differential equation. If one arbitrary constant is present, so if a given function f1 family of curves depends upon only one parameter, then the function represented sum of the form f1 equal to f1, in which it contains x, y and a, where a is some arbitrary constant. That means a function of the form y equal to a to the power x, or you can say a sin x, or some constant c to the power x, like this. So what to do? To form the differential equation, we should eliminate the arbitrary constant from the function. That means here the arbitrary constant is a, here we have to eliminate this, and here in this function we have to eliminate this. So how we can eliminate the arbitrary constant? We can eliminate the arbitrary constant by doing differentiation. So here I have written, to form a differential equation we need to eliminate the parameters or arbitrary constants by differentiating equations 1 with respect to x, and we get an equation which involving what? By differentiating y with respect to x, we will get one more term, y dash y x, and some that parameter a. So by differentiating this function, first function f1, I am getting some more function, another function, say g1 x y dash comma a equal to 0. So using the first equation and the second equation, we can eliminate the parameter a from the equation. So by eliminating, we will get the differential equation which involves only the independent variable, dependent variable and derivative terms, and no other parameters involved in this equation. So coming to an example, let's consider y equal to a into e to the power 2x, where a is an parameter or arbitrary constant. I have said we can eliminate the parameters by differentiating the equation with respect to the independent variable, where here the independent variable is x. So differentiating with respect to x, y dash equal to dy by dx, that equal to 2 into a e to the power 2x, as the derivative of e to the power 2x equal to 2 e to the power 2x, and as a is constant, that will taken outside in the beginning. So in the place of a to the power 2x, we can substitute the value y. That's why I have written here 2y as the value is given. So y dash equal to 2y, or y dash minus 2y equal to 0. So here in this differential equation, it doesn't involve the arbitrary constant a. That's why this is the corresponding differential equation for y equal to a to the power 2x. Similarly, for if a equation contains two arbitrary constants, then the function is sum of the form. So function contains the independent variable, dependent variable and two arbitrary constant that equal to 0. So here we need to eliminate the two arbitrary constant, that is a and b. So differentiating with respect to x, I will get some term, means extra term, that is y dash. So the function will be sum of the form g1 x y dash a comma b, that equal to 0. But it is impossible to eliminate two variables from two equations. So we need to differentiate the previous equation one more time. Then we will get some extra term y double dash also. So it will of the form x, y, y dash, y double dash, comma a, comma b equal to 0. After that, I have three equations. One in which we don't have y dash term. In second term, we have an extra term y dash. In third term, we have y double dash. So from these three equations, we can eliminate the arbitrary constant a as well as b. And after that, we have a function of the form in which no arbitrary constant is present. So coming to an example here, let y equal to a sin x plus b. So here arbitrary constants are a and b. So I have written here a and b are two parameters in equation 1. So which is of the form what? F of x, y, a comma b. After that, differentiating with respect to x, it is coming a cos x plus b, as it is of the form of composition function. First derivative of sin x plus b equal to cos x plus b, and after that derivative of x plus b is 1. That's why it is ax plus b. Again, I want to differentiate with respect to x because here it involves two parameters a as well as b. So y double dash equal to minus a sin x plus b, because derivative of cos x plus b equal to minus sin x plus b, and derivative of x plus b equal to 1. So here the value of a sin x plus b equal to y. That's why I am getting y double dash equal to minus y. Taking this minus y dash to the right hand side, what I will get? Y double dash plus y equal to 0. So this is the corresponding differential equation for the given function y equal to a sin x plus b, because here this equation doesn't contains any arbitrary constant. So what we need to remember, one thing, we require n plus 1 differentiation or relations to eliminate n parameters if a relation is of the form f of x, y, c1, c2 up to cn, comma cn equal to 0. That means if a function contains n arbitrary constant, that means c1, c2 up to cn, then we need n plus 1 relation. That means the original function 1 itself and the n successive derivatives. Okay, we will do some more examples. Here it is given, find the differential or form a differential equation representing the family of curves y equal to a to the power x plus b to the power minus x, where a and b are arbitrary constants. So here how many arbitrary constants are present? Two arbitrary constants, that is a and b. So we need three relations. That means the original function 1 itself and two derivatives, first order derivative and second order derivative. That's why I have written we need two more relation or to eliminate the arbitrary constant a and b. So this is the function y equal to a to the power x plus b to the power minus x. After differentiating with respect to x, I am getting the derivative of a to the power x equal to a to the power x plus the derivative of b to the power x equal to minus b e to the power minus x. After doing one more derivative, what I am getting? A to the power x, which is derivative of this term, and minus of minus, that is equal to plus b to the power minus x. So this is the value of y. That's why from comparing 1 and 3, what I am getting? D square y by dx square equal to y, which is the corresponding differential equation for the given function or family of curves y equal to a to the power x plus b to the power minus x. Here it is given family of curves, because if the value of a and b will be changed, then the curves will be changed automatically. Okay, next, coming to the example, form a differential equation representing the family of ellipse having foci on x-axis and center at origin. That means here in this diagram the center will be the origin and the focus lie on the x-axis here and here. So this is the equation of in diagram of ellipse. So what is the general form of general equation of ellipse? That is x square by a square plus y square by b square equal to 1 if the center is 0, 0. Then here a and b are arbitrary constant. That's why two arbitrary constant is present and we need two more relation. So we need two derivatives, y dash and y double dash. So differentiating with respect to x, what I am getting, the derivative of x square by a square, that equal to 2x by a square plus y square by b square, that equal to 2y by b square, into derivative of y equal to dy by dx and derivative of 1, that equal to 0. So taking this term to right hand side, what I am getting? I am getting this much, and taking to cancelled, y by b square into dy by dx equal to minus x divided by a square. After that, I am just taking the value of dy by dx from the previous, and the value of dy by dx equal to minus b square by a square into x by y, and I need the second order derivative because there is two arbitrary constant is present, and so the second order derivative y double dash equal to, as this is constant I have taken out, and here we can put the differentiation of u by v. That's why the derivative means y square, and first denominator into derivative of numerator function, that's why y into derivative of x, that equal to 1, minus x into derivative of denominator function, that is equal to x into derivative of y, that equal to dy by dx. So what I am getting, d square y by dx square equal to, here this is the term for the value b square by a square from this equation which I have written here. So putting the values of minus b square by a square, I have get the equation like this. After getting the terms y cancelled and solving this, at last I reached at the equation xy d square y by dx square plus x dy by dx whole square minus y dy by dx equal to 0. So here in this differential equation there is no arbitrary constant. That's why this is the corresponding differential equation for the function for the function or family of curves of ellipse. So here I have did one more example. What is that? If a function y equal to a to the power t plus b to the power 2t. So in this type of function, here also two arbitrary constants are present, a and b, so we need two derivatives. So this is the first order derivative, and I somehow rearranged this in the form of function y. So in place of 2b to the power minus t, I rearranged it b to the power 2t plus b to the power 2t. So this can be replaced as y, and this is equal to, in the place of these two terms, I am writing y plus b to the power 2t. So taking the y from right hand side to left hand side, dy by dt into minus y into, here e to the power 2t is producted with the term b, and taking this side it will be divided, that is and if I write in multiplication form, so it will be e to the power minus 2t, and it is equal to b. So the value of one arbitrary constant, I find it this much. After that, differentiating one more time, what I am getting, d square y by dt square minus dy by dt into e to the power t, means here I am putting the UV rule of differentiation. So derivative of first function into second function plus derivative of second function, that equal to minus 2 into e to the power minus 2t into first function, that is equal to dy by dt minus y equal to derivative of b as a constant. The differentiation is 0. So d square y by dt square minus dy by dt minus 2 dy by dt minus y equal to 0. I am getting this by taking common e to the power minus 2t from these two terms and dividing it in the another side, that means 0 by e to the power minus 2t, and this will be remain same, that is 0, and here that in these two terms e to the power 2t will be get cancelled. So this is the final differential equation I am getting for the function y equal to a to the power t plus b to the power 2t. Thank you.